Okay, that's a lot of words. So let's talk about how the data itself is actually sent and received. So won't read all of this out loud. Some of it's kind of fine print, but something to notice that once you start a connection, the connection is identified using these 5 values. And the idea is that if these 5 values are the same, then these 2 packets are part of the same connection. If any of these values are different, then the packets are part of 2 different connections. So for example, if I have 2 connections, but the port number is different, it means that those packets are part of 2 different connections. So that's something you'll sometimes see when people mention 5-tuple. Okay. And something else that we'll see eventually is that TCP will receive data, and even if the data is out of order, the TCP client or the code that's running TCP will reassemble the data into order and then present the in-order data to the application. So if you're the person writing the application, you don't have to worry about packets showing up in order. The TCP code itself will rearrange the packets and put them in the right order and then present them to the programmer. So now here's some more words that I'm not going to read out loud, but basically what we're about to show is how you actually stamp numbers onto the packets themselves. It's something we've talked about somewhat high level, and we've said just say page 1, page 2, page 3, but now we'll be more precise about how you actually stamp those numbers and also how you confirm that specific numbers have been received. That's all here in text, but I think a picture will make it more clear. So now we're going to assume the 3-way handshake has already happened, and we'll start sending data. Now, as we're sending data, we're going to fill in 2 fields in the TCP header. So remember, the header has a bunch of metadata about what's going on, and 2 of the fields in the header are a sequence number and an ACK number. And I think of them this way. The sequence number is the way you stamp a packet. So remember earlier we were saying, this is number 25, and this is number 26, and this is number 27. The way that you actually stamp numbers on data is by using the sequence number field. And what you'll do here is you'll fill in the number of the first byte in this packet. And something I've not been very clear about that I should make very explicit right now is the fact that in TCP, as it's actually implemented, we will stamp every byte with a number, not every packet. So even though intuitively it's nice to think about every page or every letter having a number, in TCP what they've done is they've given each individual byte a number. That's just how they designed it. That's why H has a number and E has a number and each of the L's has a number and so forth. And when this packet gets sent, the way you're going to stamp this packet is you're going to write a sequence number. And you'll say, this packet has all of the bytes starting at number 50. So we'll write the number 50. And then whoever receives this packet can infer that if H is 50, then E must be 51, and then this L must be 52, and so forth. So we don't really have to write every single number. We'll just stamp the packet with the first number of the first byte in that packet. So that's what this number is. So for example, if the client started at number X, then we might say that the first packet that they send starts with X plus 1. And then whatever data is here, the server, when they receive this packet, can infer that if the first byte is X plus 1, then the next one is X plus 2, and then the next one is X plus 3, and then the next one is X plus 4, and so on. And likewise, when the server sends data, it might start at Y plus 1, where Y was the server's initial sequence number. So this packet has the bytes Y plus 1, Y plus 2, Y plus 3, Y plus 4. And remember, these are 2 totally separate byte streams. And then later, if the client has more data to send, they would just continue counting wherever they left off. So for example, in this first packet, if we started at X plus 1, and we sent A bytes, where A is just some number, well, then if I started at X plus 1, X plus 2, X plus 3, and I counted A bytes, then the next byte after that in my sequence, or my byte stream, had better be X plus 1 plus A. So assuming no errors or anything, the next packet that the client sends would say, I'm going to start from x plus 1 plus a, and then the byte after that would be x plus 1 plus a plus 1, and then x plus 1 plus a plus 2, and so on and so forth. And if there's even more data to send from the server would do the same thing. If it started at y plus 1 and sent b bytes of data, then the byte after that had better be y plus 1 plus b. And this sequence continues on as long as there's data. So if you just look at the sequence numbers, the way to read them is to say, when I am sending data, this is the number of the first byte that I am sending. And who is I? That depends on who's sending data. So if the client's the one sending data, these sequence numbers are relative to the client's numbers. Because I am the client, I'm sending data, I fill in my sequence numbers here. By contrast, if you're the server, you fill in the server's sequence numbers here. I'm the server, I'm sending data, I count relative to y. That's why the client sequence numbers count up from x, and the server sequence numbers count up from y, and they're two totally separate streams of numbers. That's how you send data. Now, how do you receive data? We've talked all about sending, but we haven't said what to do if you receive data. In particular, remember we said that if you receive data, you have to confirm it with an acknowledgement. You have to say, I received the data, so that the client doesn't try to resend it again. So how are you going to confirm receipt? That's what this ACK number is for. And ACK is short for acknowledgement. So when you receive some data, you're going to reply by saying, I acknowledge that I have received some data. Now, what do you put in this number? One way to think about this number is to say, I have received all of the data from the start all the way up to, but not including this number. So this is basically a bound for all of the packets that you've received so far. So if the server sends acknowledge x plus 1 plus a, the server is basically saying, I'm going to acknowledge receipt of things from the client. This is receiving. That's why this number is relative to the client's number, because the server is receiving stuff and confirming receipt. And the server will say, everything up to x plus 1 plus a, I have received. Everything that's x plus 1 plus a and later, I have not received. That's what this is saying. So in this picture where we're assuming there's no errors, the client sends all the bytes starting from x plus 1, and there's a bytes to send. If the server receives all of that and it's all correct and uncorrupted, then the server will reply saying, I've received everything up to x plus 1 plus a. So the next time you send data, client, please start here and keep going. That's why the client starts sending from x plus 1 plus a, because the server said, I got everything up to x plus 1 plus a, so can you start here when you continue sending? And the client says, sure, I'll start there when I continue sending. And later, when the client sends starting at x plus 1 plus a and sends c bytes, if all of them are received correctly, the server will say, I've received everything up to, but not including, x plus 1 plus a plus c. So client, if you have anything else to send, start from x plus 1 plus a plus c and continue counting up. That's what the acknowledgement number says. It's you telling the other side what you have received from them. That's why you're using the other person's sequence number. So even though this is from the server, we're talking about the client's numbers because we received their data. Another way to think about the ACK, if that doesn't sound so good, is you can think of the ACK as specifying what byte you expect to receive next. So the server here is saying, everything before x plus 1 plus a has been received. The next thing I want from you is x plus 1 plus a, and the client obliges and sends it. And then later the server says, the next thing I want from you is x plus 1 plus a plus c, and the client obliges and would send that next if there are no errors. Also, note that the client is doing the exact same thing in the other direction. This is a bi-directional connection. So the server, or the client rather, is also acknowledging data from the server. So the client is saying, well, you sent me stuff starting at y plus 1 all the way up to y plus 1 plus b. So the next thing I expect to receive from you is y plus 1 plus b. And the server obliges and sends that. And at the next step, the client might say, I have received everything up to y plus 1 plus b plus d. And that's the next thing you need to send to me. So that's what it looks like. The sequence number is for data that I am sending, and it's based on my sequence numbers. And the server, or rather like the ACK number, is for data that I am receiving. And I'm talking about the other person's numbers because I'm talking about data that I received from the other person. And who's me and who's the other person depends on who's sending the packet. These blue packets, I am the client, other person is the server. The green packets, I am the server, other person is the client. So it's kind of involved. There's a lot of little math and off by ones we have to deal with, but this is how you actually stamp numbers on packets.